Welcome to Brain Vision.
We know that the weight force that acts on something nearby the surface of a massive body like a planet is given by W is equals to the mass of that object times the acceleration of gravity at the surface of this massive body. On the other hand, we know that the gravitational force is given by Fg, which is equals to big G times the mass of the massive body, the mass of the planet, of the star, of the comet, of this massive body that is producing gravity, times the mass of the object that's nearby the surface, divided by r squared. This r squared is the distance between the object and the center of the massive body. For instance, we have here on the left the surface of planet Mars. If we have an object that is hovering right here, this little r on the Fg equation would be this distance, the distance between the center of planet Mars and the body that is under the effect of its gravity. Now, by comparing this equation with this equation, we see that we can identify this quantity as being the acceleration of gravity at the surface of some massive body. In our case, we want to calculate the surface gravity of planet Mars. So, using this equation that we had just derived, sort of, we have G is equals to big G times m divided by r squared. Then, by plugging in the known values, we get G times 6.46 times 10 to 23 divided by 3.39 times 10 to the 6th squared. Now, what is the value of big G? This is the value of Newton's constant, and this is approximately 6.67 times 10 to minus 11 Newtons meters squared divided by kilograms squared. Then we have the following surface gravity for planet Mars. The surface gravity is equals to 6.67 times 10 to minus 11 times 6.46 times 10 to 23 divided by 3.39 times 10 to the 6th squared, and this is approximately 3.75 meters per second squared. On the next item, there is a person of mass m equals to 65 kilograms on the surface of Mars. How much would this person weigh? Well, to answer this question, we have to use these values for the acceleration of gravity with this equation for the weight force. Then we have the following. The weight of that person is equals to 65 kilograms times 3.75 meters per second squared, and this is approximately 2.4 times 10 squared newtons.